Have you ever wondered how a website like Amazon just knows what you ordered a year ago? Or how a huge university can keep track of thousands of students in classes without everything just falling apart? Well, it's not magic. It's actually a really elegant and powerful way of organizing information. So let's pull back the curtain and take a look at the fundamental building blocks of a database. All right, here's our game plan. First, we're going to cover what a relational database even is. Then, we'll break it down into its basic parts. After that, we'll look at how we solve a really common problem, making sure everything is unique. Then comes the fun part, connecting all the pieces. And finally, we'll see why this whole structure is just so important. Okay, let's start with the 30,000-foot view. Before we dive into the nuts and bolts, what are we even talking about when we say relational database? Let's get the main idea down first. At its heart, a relational database is really just a collection of tables. But the magic word here is relational. These aren't just a bunch of separate lists floating around. Nope, they are specifically designed to be linked together, creating this whole web of connected information. And I love this analogy. Just imagine you have one spreadsheet with all your students' names, and you've got another one with all the courses offered. A relational database is the thing that lets those two spreadsheets talk to each other, so you can instantly see which students are taking which classes. That simple connection? Well, that's the key to everything. Okay, so we've got the big concept down. Now let's roll up our sleeves and actually start putting something together. It's time to build our very first table. The most fundamental piece of this whole puzzle is the table. And here's the golden rule, the most important thing to remember. Each table should be about one thing and one thing only. So you'll have a table for students, a totally separate table for courses, and another one for teachers. This focus is what keeps the whole system from becoming a mess. And here is a perfect example. Take a look at this students table. Every single piece of information here, the ID, the first name, last name, the major, it's all about one thing, the student. We're not mixing in details about their classes or their teachers' phone numbers. It's clean, it's focused, and it's all about one thing. So if the table is the container, then a row is a single item inside that container. Looking at that first line, for example, gives you the complete record for one person. John Smith, ID 1001, and IT major. That one row is a complete snapshot of that one specific student. And the final piece of our table is the column. You can think of these as the categories for our information. You have a column just for first name, another just for major. They provide the consistent structure for every single record for every row in our table. Okay, so we've built our table. But this brings up a huge potential problem. I mean, in a big school with thousands of students, what happens when you get two people with the exact same name? How do you avoid a massive mix-up? Well, our next building block is the ingenious solution to that problem. Seriously, just think about that for a second. A brand new John Smith enrolls. How does the system know he's not the other John Smith? How do you make absolutely sure you're giving a grade to the right person? Names just aren't reliable enough. We need a unique identifier that is guaranteed to be different for everyone. And that solution is called the primary key. That student ID column from our table, that's a perfect example. That's our primary key. We could have 10, 20 students named John Smith, but the student ID 101 will only ever belong to one of them. It's like a unique fingerprint for every single row in the table. Now, for this whole system to work, a primary key has two unbreakable rules. First, it has to be totally unique. No two rows can ever share the same primary key. And second, it can never be empty. Every single student has to have a student ID. These two simple rules are what make it so reliable. So, this is where it all comes together. This is the part that puts the relational in relational database. We have our separate tables, we have our unique identifiers. Now, let's create the connections that give this system its incredible power. This is the real magic. So how do we make that connection happen? We use something called a foreign key, and it sounds technical, but the idea is simple. A foreign key is just a column in one table that points to the primary key in another table. That's it. It's the bridge that connects table A to table B. Let's make this real. Check out this enrollments table. Its only job is to connect students to courses. Notice that student ID column? That's our foreign key. The number 1001 doesn't mean much by itself, but it acts as a pointer, a direct link right back to John Smith in the students table. We don't have to repeat his name or major, we just reference his unique ID. It's so efficient. And the course ID column does the exact same thing for courses. That is the relational magic in action. Okay, so you might be wondering why all this fuss about different keys and tables. It might seem a little complicated, but this structure is what transforms messy data into a powerful, trustworthy source of information. Let's really dig into why this matters so much. Take a look at this comparison. On the left is the messy way. Every single time a student signs up for a class, we type out their full name and their major all over again. Imagine they change their major. You'd have to find and update it in like a dozen different places, hoping you don't miss one. Now look at the better design on the right. The student's info is stored exactly once. We just use their ID to link to it. It's way more efficient and way less likely to have errors. And there's a name for this process of designing your database to avoid repeating yourself. It's called normalization. It's just the formal way of organizing your tables to cut down on that redundancy and make sure your data is reliable. It's what ensures that when you update a student's info in one place, it's correct everywhere, automatically. To really lock this all in, let's use a physical analogy. Imagine your whole database is a big filing cabinet. Each drawer is a table, so you have a student's drawer, a courses drawer, and so on. Inside a drawer, each individual file folder is a row. The unique label on the front of that folder, the one that says 1001, that's its primary key. And a little sticky note inside that folder that says See Course Folder 200, that's your foreign key. It's just a simple pointer telling you where to find related information. So, let's do a quick recap of the key takeaways. Databases organize information in related tables. Inside those tables, rows are the individual records, and each one is identified by a unique primary key. We use foreign keys as the bridges to connect these tables together. And the whole point of this structure is normalization, to get rid of duplicated data and keep everything accurate. And there you have it. That's the basic blueprint for how pretty much all modern data is organized. So I'll leave you with a final question to think about. Now that you know these building blocks, where in your own life, your work, or even your hobbies, could this structured way of thinking, using tables, unique keys, and relationships, help you bring a little bit of order to the chaos?